Hello, Mr. Crawford's class. It's April 27th, and let's keep rolling on the hierarchy of quadrilaterals. I wanted to tell you something about the last quiz real quick about a kite. A kite, its property is two pairs of equal length adjacent sides. On the quiz on Friday, I left out adjacent, which means it was just two pairs of equal length sides, and it doesn't change my answers on the quiz because the only property that describes a shape like that is a kite. We don't use that for any of the others. So I didn't change the answers, but I will adjust that for the grade so that you get, because some of you made a great connection with that property and you applied it to the other shapes in the descriptions of the other shapes, which means that you guys were doing a little bit what I'm going to be asking you today is you're applying properties to shapes to see if it's true or not, which is going to be awesome today. So today what we're going to do is we're going to look at always, sometimes, or never. This is going to help us apply the rules of the hierarchy. So a hierarchy is an inclusive system to rank shapes. So to make that very clear, a quadrilateral is four sides and four angles. So if a quadrilateral is four sides and four angles, that means all of these shapes can sometimes be a quadrilateral. All right. A quadrilateral will sometimes be one of these shapes. All right. So let's take a look at a quadrilateral. A quadrilateral is a trapezoid. Always, sometimes, or never. Sometimes. Because if you apply the property, all right, if you draw a trapezoid, you're going to have one pair of parallel sides, and you're going to have, and that's it. But that's more than what a quadrilateral is. So some quadrilaterals with that property will be a trapezoid. Now, are all trapezoids quadrilaterals? Yes. All right. All trapezoids are quadrilaterals, just like all parallelograms are quadrilaterals. All right. But when you apply a property to it, to a quadrilateral, like at least one pair of parallel sides, it becomes a trapezoid. So only sometimes will a quadrilateral be a trapezoid. Just like with a kite, right? Just like with a kite, you can have all kites are quadrilaterals, but only some quadrilaterals become kites. All right. So on the way down, a quadrilateral can become other shapes, but some of the time. All right. But let's now think about it going in different ways. All right. Can a trapezoid is a trapezoid a kite? Always, sometimes, or never. Is there some way we can apply two sides of adjacent, two equal length sides of two equal length pairs of sides that are adjacent to each other? Can we do that with a trapezoid? Can we sometimes make a trapezoid fit that property? Can we sometimes have one pair of parallel sides with our property of a kite? Never. We can never do it. It won't work. So that means that never would be the statement for is a trapezoid a kite? It can only be that, never the time. All right. So that's one example of how this could work, how the hierarchy works. All right. Some shapes with its properties allow it to be always a shape, sometimes a shape, or never a shape. So let's look at a rectangle. So now we have a rectangle. We have two pairs of parallel sides, four right angles. A rectangle is a parallelogram. Sometimes, always, or never. Which one would make it true? Well, let's apply the property of a parallelogram to a rectangle and see if we can come up with an answer. Will a rectangle always have two pairs of parallel sides? Yes, it has to, because you have 4 right angles with lines connecting them. There's no way you can write uh, a shape that has 4 right angles without having 2 pairs of parallel lines connecting them. There's no way. So always would be the answer. A rectangle will always be a parallelogram. All right. Now, let's think about it this way. Always, sometimes, or never. Which one would make it true? A rectangle is a kite. Always, sometimes, or never. So now we got to apply this property of a kite to a rectangle and see if it can never be it, can sometimes be it, or always be it. So we have adjacent sides. So we need this side and this side to be of equal length because they're adjacent to each other, next to each other. That doesn't work. What about here? That doesn't work. What about here? That doesn't work. What about here? That doesn't work. All right, so can a rectangle ever be a kite? It can never be a kite because you can never form a rectangle that has 2 pairs of equal length adjacent sides and still have your rectangle. It can't work. So a rectangle can never be a kite. All right. So last thing I want to talk about is a square. All right. We have a square. All right. We now have a square. All right. Let's talk about some always, sometimes, and never of a square. A square has 4 right angles, 4 equal sides. All right. So a square is a square ever going to be is a square a square is a rectangle. Always, sometimes, or never. Well, let's apply the rectangle. Does it have 2 pairs of parallel sides? Does a square have 2 pairs of parallel sides for a rectangle? Yes. Does a square have 4 right angles? Yes. So a square is always a rectangle. What about a square as a parallelogram? Always, sometimes, and never, a square is a parallelogram. Well, all a parallelogram's property is 2 pairs of parallel sides. Apply that to a square, what do you have? Yes, you do. So it's always. Now let's talk about a trapezoid. Is a trapezoid with 1 pair of parallel sides, is a square ever going to be a trapezoid? Well, if we apply the properties of a trapezoid to a square, it's never going to happen. Because a square can never have less than 2 pairs of parallel sides. So never. A trapezoid could never be a square. All right, but some trapezoids can be a square. That's what we got to recognize is some trapezoids will have 2 pairs of parallel sides and 4 right angles and sides of equal length. So sometimes a trapezoid can be a square, but a square can never be a trapezoid. All right. So you have to apply the property of the 2 shapes you're comparing. You have to apply the property to the shape you're comparing and see if you can make a shape that's always that shape, always a quadrilateral, always that way, sometimes or never that shape. So it takes a little bit of critical thinking, but you got to just remember, apply the properties of the shape you're comparing it to and see if it's always that shape, never that shape, or sometimes. And I trust that you'll be able to do it. It's like mapping it out. All right. So let's keep forging ahead. Get outside today. Don't sit in front of a computer all day. And I'm thinking about you all the time. Have a great day. Email me if you have any questions. Mr. Crawford is out.